The 1999 downing of an F-117 over Serbia shocked the world. Stealth wasn't invincible. This revelation pushed nations into a technological arms race that would redefine air dominance forever. Let's start with the first-generation demonstrators. The problem was simple. Soviet radar networks could track anything America flew. The solution would require radical geometry that seemed impossible to control. Enter Lockheed Have Blue, the hopeless diamond. With wings swept back at an extreme 72.5 degrees and a fuselage built entirely from flat-faceted panels, it looked more like a crashed UFO than a functional aircraft. Both prototypes ended up smoking holes in the desert during testing. But before they died, they proved something revolutionary. You could make an airplane invisible to radar. Every stealth aircraft that followed owes its existence to those two doomed test birds. While Lockheed was shattering expectations with flat plates, Northrop took a different gamble. Tacit Blue looked like someone inflated a school bus and tried to make it fly. Engineers called it the whale for good reason. But beneath that ungainly exterior lay smooth, continuous curves that proved stealth didn't require brutal faceting. The aerodynamic efficiency unlocked here would flow directly into the B-2 Spirit, bridging the gap between the first generation's compromises and the elegant designs that would come later. Up next are the first-generation operational aircraft, designed to penetrate the heaviest Soviet air defenses and return alive. When the F-117 Nighthawk finally went operational, it looked like nothing that should be able to fly. This angular black jet had gold-coated windows to stop radar from bouncing off the pilot's helmet, and weapons bays sealed so tight you couldn't see a screwhead. It was subsonic, couldn't dogfight, and handled like a brick with wings. On January 17, 1991, it became the only aircraft cleared to strike downtown Baghdad on the opening night of Desert Storm. By the end of the war, it had delivered 1,600 direct hits on high-value targets without a single loss. The legend of stealth had arrived in fire and precision. If the F-117 was a scalpel, the B-2 Spirit was a sledgehammer wrapped in silk. This flying wing stretches 172 feet from wingtip to wingtip, yet its radar signature is smaller than a marble. Carbon graphite composite skin absorbs radar waves, while engines buried deep in the wing suppress heat signatures. During the Kosovo War, B-2s flew 30-hour round-trip missions from Missouri, refueled over the Atlantic, struck targets, and returned home, all without leaving American airspace for basing. At $1.4 billion per aircraft, it's the most expensive bomber ever built. It's also the only platform that can hold any target on Earth at risk with virtually no warning. Now shifting to the second-generation fighters, where stealth finally merged with supersonic performance and knife-fight agility. The F-22 Raptor rewrote the rules. Previous stealth aircraft sacrificed speed and maneuverability for invisibility. The Raptor refused to compromise. Thrust vectoring nozzles let it turn impossibly tight. Supercruise lets it sustain Mach 1.8 without afterburners, preserving both fuel and stealth. Its radar cross-section remains the size of a marble while pulling 9 Gs at supersonic speeds. Only 187 were built before Congress killed the production line in 2011. A decision that looks increasingly short-sighted as peer adversaries deploy their own fifth-generation fleets. Mass production arrived with the F-35 Lightning II. 3 variants: conventional, short takeoff, carrier, replacing everything from a 10 Warthogs to F/A-18 Hornets across the US military and Allied air forces. What makes it revolutionary isn't just stealth, it's the sensor fusion. Distributed aperture cameras give pilots a 360-degree view, literally letting them see through the floor. Every F-35 becomes a node in a networked battle space, sharing targeting data with everyone from Aegis cruisers to Army artillery. Over 1,000 have been delivered by 2026, making this the first stealth fighter to achieve true mass production. Another key group emerged from the Chinese fifth-generation programs, designed to challenge American dominance in the Pacific. China's J-20 Mighty Dragon wasn't built to dogfight F-22s. It was built to kill the tankers and AWACS platforms that enable American air power. This long, canard-equipped interceptor prioritizes speed and range over agility. Early models relied on underpowered Russian AL-31 engines, limiting performance. By the mid-2020s, the fleet transitioned to indigenous WS-15 engines, finally unlocking true supercruise capability. Those canards, typically terrible for stealth, are software-controlled to align with the wing during cruise, minimizing radar spikes. It's a high-speed missile truck aimed at cutting American power projection off at the knees. For years, the Shenyang J-35 existed in limbo, an FC-31 demonstrator searching for a mission. Then, in September 2025, it landed on the electromagnetic catapults of China's newest carrier, the Fujian. Folding wings, reinforced landing gear, and full stealth certification made China the second nation ever to field a carrier-capable stealth fighter. A land-based variant, the J-35A, entered PLAAF service simultaneously, giving China both a naval strike platform and a medium-weight complement to the heavy J-20. The program's success signals that China can now develop multiple concurrent stealth platforms, a capability only the United States previously possessed. Late 2024 brought satellite images of something new at Chengdu Aerospace, a tailless diamond platform aircraft that aviation analysts are calling the J-36. The configuration suggests broadband stealth, effective against the low-frequency radars that can sometimes detect traditional stealth shapes. If operational, it represents China's answer to the American NGAD program, a sixth-generation design before the fifth generation has even matured. Limited information exists, but the message is clear. China isn't following the stealth roadmap. It's trying to write the next chapter. We now turn to the Russian approach, where sanctions and budget constraints forced a focus on standoff lethality over deep penetration. The Su-57 Felon is the least stealthy of the fifth-generation fighters. Exposed engine faces, round IRST housings, and legacy nozzles on early models give it an RCS closer to 0.1 to 0.5 square meters, orders of magnitude larger than American or Chinese equivalents. Production numbers remain low, with fewer than a regiment operational by 2025. But in Ukraine, it found its role, firing long-range R-37M missiles from inside the protective umbrella of Russian air defenses. It doesn't need to survive deep penetration missions if it can kill enemies from 200 kilometers away. The Su-57 represents a different philosophy: good enough stealth paired with extreme standoff capability. Russia's export play is the Su-75 Checkmate, a single-engine light fighter promising fifth-generation performance at fourth-generation prices. Supercomputer-designed geometry and a distinctive chin intake give it a futuristic appearance. Sanctions from the Ukraine war delayed everything, but the first flight-ready prototype emerged from the factory in late 2025. Whether it can deliver on its promises remains unproven, but for nations priced out of F-35s or facing Western arms embargoes, the Checkmate could reshape the market if it ever reaches serial production. Finally, the stealth unmanned combat air vehicles, where removing the pilot unlocked capabilities no manned platform could match. Northrop Grumman's X-47B made history on July 10, 2013, the first autonomous carrier landing. No pilot, no remote control, pure computer decision-making bringing a jet onto a pitching deck at sea. 2 years later, it completed the first unmanned aerial refueling. The technology was proven, the path forward clear. Then the Navy pivoted to the MQ-25 tanker drone, shelving the combat potential. The X-47B demonstrated what was possible. Whether that potential gets realized remains an open question. Operational stealth drones do exist. The RQ-170 Sentinel, the Beast of Kandahar, has been flying ISR missions since 2007. One was famously captured by Iran in 2011 after a navigation failure, but the fleet continues to operate over denied airspace. Its bigger cousin, the RQ-180, may be the most significant classified aircraft in the U.S. inventory. With an estimated 130-foot wingspan and high-altitude endurance rivaling the U-2, this great white bat has been penetrating contested airspace since approximately 2015, conducting strategic reconnaissance that no satellite can match. China's GJ-11 Sharp Sword represents Beijing's parallel development path. This flying wing carries weapons internally and features a stealthy exhaust system designed to operate as both an autonomous striker and a loyal wingman to manned J-20s. Meanwhile, Russia's S-70 Okhotnik B takes unmanned combat to the extreme, a 20-ton beast with a payload capacity exceeding most manned fighters. Later prototypes feature flat nozzles for infrared suppression. Serial production is expected to begin in 2026, creating a heavy strike platform that can absorb losses no manned aircraft could sustain. Turkey's aerospace industry delivered perhaps the most surprising development. The Bayraktar Kızılelma is a jet-powered, canard-equipped combat drone capable of carrier operations and supersonic speeds. It successfully completed deck tests and demonstrated air-to-air potential. Turkey has effectively created the world's first stealth carrier UCAV outside the US-China duopoly, leveraging its successful drone industry into cutting-edge combat aviation.